The last gas law we're going to look at is Dalton's Law of partial pressure. What Dalton's Law of partial pressure tells us is the total pressure of a gas mixture, okay, so we got more than one gas in there, is the sum of all the partial pressures of all the gases that are in there. So if you've got three different gases in there, A, B, and C, then the total pressure is equal to the partial pressure of A plus the partial pressure of B plus the partial pressure of C. This is like one of the very, very simplest ones, even with math, okay? So you got a sample of exhaled air containing four gases with the following partial pressures. The only thing you got to make sure is that they're all in the same units, all right? So you've got N2, which is 563. You've got O2, which is 118. These are all in millimeters of mercury. CO2, 30, and H2O, 50. What is the total pressure? The total pressure equals the pressure of nitrogen plus oxygen plus CO2 plus water. So the total pressure is 563 plus 118 plus 30 plus 50, and they're all in millimeters of mercury. So you just add those up and you get 761. I bet you hope that I give you a whole bunch of those on the test. All right, let's do one more. For a deep dive, a scuba diver uses a mixture of helium and oxygen with a pressure of 8 atmospheres. Okay, so it's telling you that the mixture is 8 atmospheres. What does that mean? That means P total is equal to 8 atmospheres. All right. If the oxygen has a partial pressure, so we write that partial pressure of oxygen is equal to 1280 millimeters of mercury. What is the partial pressure of helium? Because we've only got those two things mixed together. Now we know that P total is equal to PO2 plus PHE because it's just the total of the partial pressures. What we need to look at though before we start plugging stuff in is we got one in atmospheres and we got one in millimeters of mercury. You can do those in either one you want to. If you're doing a multiple choice test, I'd look and see what the answers are in on the multiple choice and convert them that way, because you can either convert atmospheres to millimeters of mercury or you can convert millimeters of mercury to atmospheres. I'm going to convert the millimeters to atmospheres. So, and you do it with the same one. You'd say times, there's 1 atmosphere in 760 millimeters of mercury. And so 1280 millimeters of mercury gives me 1.68 atmospheres. 1.68 atmospheres. I don't know why it does that line through it sometimes. Okay, so I got 1.68 atmospheres and I got 8 atmospheres, so they're now in the same unit. So this is P total and this is the partial pressure. So instead of me adding stuff together, I'm going to have to say the total pressure minus the pressure of oxygen is going to give me the pressure of helium. See why? Because I've got the total one and then I've got this one, right? So I'm solving for helium. So the total pressure, which is 8 atmospheres, minus the partial pressure of oxygen, which is 1.68 atmospheres, gives me 6.32 atmospheres of helium. And if I want it in millimeters of mercury, I could still say 6.32 atmospheres times 1 atmosphere. Got to go on the bottom, right? Because I got to cancel it. 760 millimeters of mercury, and that's going to give me 4,800 millimeters of mercury. That's Dalton's Law of partial pressure.